Hello, viewers! I welcome you again in our Joko learning series. And with today's topic about learning cryptography, I'm going to talk about some example of one-time pad concept. One-time pad is a part of polyalphabetic cipher, and it's actually a derivative of Viginere cipher. The other type is about monoalphabetic cipher, such as Caesar's cipher. Both of these classical type is called classical cipher because it is not used in modern system. It is very weak in today's standard, but I will still share this with you because it is essential in pedagogical learning. It introduces us to confidentiality concept, demonstrate key sharing, and prepare students for understanding the modern cryptography. So let's deep dive into it for one-time pad concept. I'll call this in simpler form, it is OTP. The OTP is simplest stream cipher that can be practiced with pen and paper. We have no machine needed. And we learn this to strengthen the concept and our understanding about stream cipher. But you should note and know that the algorithm itself is not used in the real world anymore. Now, how to use it in encryption? There are a few steps. First, we define the alphabet map and modulo number. And then we convert the plain text using the alphabet map. And then we provide the key stream. The best is random. And convert it using the same alphabet map. And then we encrypt it with modulo addition and change it back to character. Then it becomes the ciphertext. So we're going to use modulo addition, but in essence, in mathematical, it's actually almost the same with XOR functions. Now, I need to explain first that this example of one-time pad is not really a real one-time pad. It's just for the basic concept, because the true one-time pad will use truly random key, will use a key length that is greater than or equal than plain text length, where the key is never used, will not be repeated, and it's kept secret. But for today's concept, I'll use a simpler form of key that will be repeated. Okay. Now, the first step is to define the alphabet map and modulo number. So in here, as you can see, I have mapped the character of Latin letters from A to Z and including a space. We have 26 characters, 26 letters. With a space, it's become 27. And because I map A is 0 and then Z is 25, I'll put space here in 26. The total character, including space, is the modulo number, which is 27. We will use this alphabet map for our concept of encryption. The second step is to convert the plain text using the alphabet map. The example of the plain text, I will put here, there are 9 letters, hello, space, Joko. And I will map each letter to the corresponding number. Extra gracia, H becomes 7, A becomes 0, L becomes 11, O becomes 14, space is 26, and so forth. The third step is to provide the key stream. As I have stated earlier, it should be random, but for this example, I will just use a very simplified one. It's the word keys. I will convert it using the same alphabet map. I've mapped K into 10, E into 4, Y into 24, S into 18. The fourth step is I will encrypt it with modulo addition and change it back to character. The encryption rule is the ciphertext will be the plain text number plus the key stream number, and then after adding that number, we do modulus 27 operation. I have made the table here. So H become 7, and we put it in synchronous with the key. The key itself is the word keys, and I've repeated for as long as it needed, as long as the plain text. So H will correspond to K, which means 7 is the number for H and 10 is the number for K. When we add it up, it becomes 17. 17 modulus 27 is still 17, so it will become the cipher R. Romeo. I will turn back here. R, 17. So as you can see now, we just map it along each character. A for a number of 0 with the key corresponding to E, and then the number for the key is 4. 0 plus 4 is 4. 4 modulus 27 becomes 4, and 4 is E. So the cipher is now R and E, Romeo and Echo. And then the next plane is L, and then we add 11 with the key, corresponding key is Y, it's 24. 11 plus 24 is 35. 35 modulus 27 becomes 8, and 8 is the character I. And so forth until the last character or the last letter that we want to encrypt. So we now have the ciphertext R, E, I, F, J, N, L, B, Y. That's the ciphertext. That's the one that's being transmitted to the receiver or being stored. Now, how do we reverse or decrypt this? As long as the receiver have the same mapping, alphabet map, and knows the key, then the receiver can do the decryption using the same techniques, only being flipped. So it will use the same alphabet map and modulo number. It will convert the ciphertext again using the alphabet map. And then it will do it using modulo subtraction, not adding. Whereas the final number will be changed back to a character, which is the plain text. Here's how we do it. We have the ciphertext R, E, I, F, J, N, L, B, and Y. So R will be 17, E will be 4, and so forth. This is remapping again to the number according to the alphabet map. We still use the same key stream and convert it with the same alphabet map. The key is keys. And we use the decryption rule plain text equals cipher subtracted with key stream modulus 27. So using the same pattern, now we have the cipher R, and then the corresponding number is 17. It is with the key K, and then the corresponding number for the key K is 10. 17 minus 10 is 7. 7 modulus 27, still 7. And when we remap it again, 7 is the letter H. We do this for all of the letters, and if the cipher number is lower than the key number, for such as in the the letter I, here, the number is 8 with the key Y, the number is 24. 8 minus 24 will be minus 16. It's okay if we have minus number. We'll just need to add 27, the modulus number there. 16 plus 27 becomes 11. 11 modulus 27 will still be 11. So the plane will be L. And so forth until the last letter, then we'll get again the plain hollow Joko with the space included. So that is the example of one-time path concept practice. For your own active understanding, I ask you to discuss or try to find out what happens if the key stream is reused for creating many other ciphertexts again and again and again. Okay, that's for today's sharing. I thank you for watching. Don't forget to like and subscribe. See you later. Bye bye.